Now we are going to see object-oriented programming in Java. So as we already discussed the pillars of object-oriented programming: abstraction, encapsulation, inheritance, and polymorphism. So let us start with abstraction, hiding complex details and showing the relevant details. So let's do a practical of that. So in Java, I will be starting with a class. Let's say the class name is abstraction. So I will be showing an abstraction and encapsulation together, right? So abstraction, encapsulation. So in one demo, both will be done. Now here in this class, I'm creating something as public, right? Let's say I'm creating a public method. And now when I want to display this in another class where I'm going to create the main method, so now if I create the object of this class, so I can call this method. So I can call this method from this OP class because this method is public, right? So let us see this practical. So let me compile this. Compilation successful, and execution is successful, and you can see the output as hello, right? Since the method is public. So that means I am exposing this, right? I'm exposing this. So this class is able to call this method because I have exposed this method. Now let me make it private, right? Now see that if I compile this now, you're definitely getting an error. So it's saying this has private access, so it cannot be accessed outside. So since this OP class is outside this abstraction encapsulation class, I'm not able to access this. So this is how we are actually doing the encapsulation of this method inside this class, and that is the reason we are able to control whether this method, the member of this class, can be accessible outside this class or not. So when it was public, it was accessible here. When it is private, it is not, right? So let me bring you to the presentation once again. So hiding complex details. So those details which you want to hide, you can make it private, right? And show the relevant details. So those details which you want to show, you need to make it public. So let me just create one more method. Let's say this disk is private. Now let me create one more method which is public. So now you can see that here in this example, I have this show method which is public. So I can call this show method from outside, but I cannot call this disk method. So this is how I'm controlling what to show and what to hide, right? And now if I simply compile this, you will see that now it's got compiled and it got executed. So this was the demonstration for abstraction and encapsulation, right? Now this is what the first example where it is private, so nothing is visible from outside, everything is packed within that box. And then in the case of this laptop, as I said that the keypad is visible, the monitor is visible, but internal circuitry is hidden. So in the similar way, we have shown the show method and we have hidden the disk method, right? Now encapsulation, as I already discussed, that is wrapping up. So this class here is actually acting as a wrapper, right? So this class is hiding these things. So because of this class, which is acting as a structure, which is providing that body, right, within which you are containing the methods or the variables. So that is the reason you're putting this public and private. Otherwise, how can you control this, right? Just imagine C. right? If you have worked on C programming, there we cannot write this private and public over there directly, because there it is a function, right? And those functions we cannot put the public or private, right? We do have structures in C, but that is a different scenario, right? But this is what you need to understand. One more thing we need to understand here is function versus method, right? In Java we have methods, we do not have functions, but in C++ we have functions and we have methods. Now what is a method? Method is something which is created inside a class, right? So main here is a method, but in the case of C and C++, main is a function, because main is created outside a class, right? So that is something which you need to remember. Now let us go ahead and talk about the inheritance. So let me show you one example of inheritance now. So I'm going to create a class, let's say parent, and within this parent class I'm going to create a method, the same method, let's say void public, void disp. Within this disp method I'm going to display parent, and I'm going to create a child which is going to inherit parent. So the keyword in Java is extends, and you can see that currently this child class is having nothing, right? Now let me create the child object. Fine. So let me create this child object. Now once I created this child object, and if I compile this, there was a typo. Okay, now you can see that okay, I haven't called the method. Now even if I write this disp, you can see that now it is still able to call the parent method, because child is now reusing the parent's code. That is a benefit of inheritance, right? So now you can see that even though this child class is empty, then also it's able to call the parents method because it is inheritance, right? That is the main benefit of inheritance, reusability, right? Now let me just show you a few more examples of this. So if I create this method, I think this main functionality of parent child is clear, right? Now I can have, let's say, the method of child also. So let's say void show, and here I am writing child, and then c dot show. So now you can see that child is able to access his own methods, plus he is able to access his parents methods. So parent and then child, right? So this is what you can notice here. Fine. So this is about inheritance, but now we are going towards the next very important topic, which is composition. So as you can see here that we do not need a inheritance in this particular example. What we can do, rather, we can do a composition. Let me show you how we can achieve the same output by using composition. So if I just remove this extends parent, right, and if I just want to call this parent here, I can simply create the parent object, and I can call the method. So this is called composition, right? So I will simply call this show, which will call the disp also. So again you can see that the scenario has changed. The output is still the same. So as I told you in my previous video also, that if you want to do the same task, right? If the same task is possible by using composition and inheritance, you should prefer composition because it is less complex, right? So the complexity is lesser in this case. Got the point? So this is what you need to take care. Now, going further to polymorphism. So now we will talk about polymorphism. So I think this part is clear, that is inheritance versus composition. So if both are possible, right, then you should prefer composition, but then there are scenarios where only inheritance will be possible, right? So as we have already seen that parent and child relationship will be maintained in the case of inheritance, but in the case of composition you are creating the object within that class, so you're using that, right? So that is the composition relationship, that is called is a, this inheritance is called is a relationship, and composition is called has a relationship, right? In theory this is how they explain in books. Now we are talking about the polymorphism. So let us see the static polymorphism first, that is overloading. Okay, so in the case of overloading, so I will go with, let's say this parent, let me just remove this child class for now. So I have this disp method. So let me just copy this method and paste it once again. So this disp is having 0 parameters. Now let me add one more parameter here, and when I have added one more parameter, let me display that. So parent plus I. So now if I am creating the object of parent class, now in this case I can see that there are two disp methods available. So if I do not pass any parameter, it is going to call the first one, and then if I am passing any parameter, it is going to call the second one. So this is the inheritance, and sorry, there is no inheritance. This is the polymorphism, which is static polymorphism, which is known as method overloading, right? So these are the overloaded methods. Right, so you can see that this one is calling the first method, right, this one, and this one is calling the second method. So this is how you can understand that this is called method overloading, because we are having same named method, right, multiple times in the same class, but what they should be having different, they should have the different parameters, which we call it as signatures. So there are three types of signatures. So let me just name them. The first one is as a part of signature, the first one is number, that is like if I say void disp, the first one is 0 parameter and the second one is, let's say, having 1 parameter. That is what is a number difference. Now the second one is type. So let's say I said void disp, and then first one is, let's say, int a comma int b, and the second one is void disp, and then you have double a and double b. Now here also you can see that name is same, number is also same, so both are having 2 parameters, but their types are different. And the third one is sequence. So I'll just take the example of type. So here it is, let's say, int and double, and here it is double and then int. So number is same, type is same, right, but the sequence is not same. So by following any of these 3 rules, you can do overloading of the methods. Now this overloading of the method is still possible in parent-child relationship, right? So let me create a child class. And within this, if I create the second method. Okay, first of all, it should remain the same if I create the child object. So you can see that the output is still the same. Now if I just put this in the child, now you can see that it is still possible. So your overloading can be possible with parent-child relationship, right? So this is you need to understand here. Fine, this is about overloading. Now let us talk about overriding. So overloading means that the same method name with different signature, with different parameter. Now overriding will be when the same method name with the same signature is there. So this is overriding now. So now this program has got changed from overloaded to overridden. Now this disp method is going to override the parent's disp. Let me show you the output. So now the output will be child. Why? Because I am creating the object of child. Child has access for the parent method as well as the child method, but since it is already available in child, it will not take the method from parent. That is what happens in real life also, right? Let's say for example, you take pocket money from your parents when you do not have any money, right? When you do not earn. But once you start earning, you do not ask for pocket money from your parents, isn't it? So that is what is this is example, right? So since the child is having its own disp method, it is not going to take the parent's disp method, right? But still if you want to call that, right? So in that case you have the super keyword. So using this super keyword, you can call the parent's disp method. Otherwise it's simply going to override, right? So this is how you can simply use that. So super.disp is going to use is going to call the parent's disp method, and then the child disp is further continuation of that. This is useful, right? This is reusing the old code, the parent's code, and then adding the functionality to it, right? This is called overriding. Now there are several other things which we need to talk about. That is, like, if you have a parent reference and child object, right, then what is going to happen? So there are also several things, like if right now it is child object and child reference. Now what about if I create parent p is equals to new child? This is also something which is possible. So parent reference can hold child object, and then p dot disp. Now in this scenario, which method is going to be called? That is something interesting, right? So it is still the child, right? Now remember that this output depends from programming language to programming language. Since we are using Java, so in Java it is going to be child, right? But if I use, let's say for example, C#, so there it will be parent, right? So unless and until you write override keyword in C#, it will not be like this. So it depends on programming language to programming language how this particular program is going to work. So in the upcoming videos, I will be definitely showing you the C# also. But now that's it for today, and this is, I hope you have understood the basic concepts of object-oriented programming.